आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
The question states two cylindrical hollow drums of radii r and 2r and of a common height h are rotating with angular velocities omega anticlockwise and omega clockwise respectively. So the first drum is rotating with an angular velocity omega in an anticlockwise direction, and the second one is rotating with again same angular velocity omega but in the clockwise direction. Their axes fixed are parallel and in a horizontal plane separated by 3r plus delta. So their axes are fixed and they are separated by a distance of 3r plus delta. They are now brought in contact such that delta tends to 0. Show the frictional forces just after contact. See what is happening. Initially, the axes were separated by a distance of 3r plus delta, but now we are bringing them closer such that, let's say this is the sphere or holodrum of radius r, and this is the holodrum of radius 2r, but we have to bring them closer, so I need to raise this one and draw another one that is closer to it. Okay, like this. So now we are bringing them closer such that the distance between their axes of rotation, which are fixed, becomes 3r. Okay, delta tends to 0, that means the total distance between them becomes 3r. That is obvious because the radius of this is r and the radius of this is 2r, so the total distance between their axes is 3r. Okay, the first question is show the frictional forces just after contact, and this one is moving in an anti-clockwise direction with an angular velocity omega, and this one is moving in the clockwise direction with the angular velocity omega. See now what will happen. Let's suppose at the point of contact, this point, we know when do frictional forces come into existence? Only when there is contact, there's like the two bodies, two surfaces touch each other. So these two surfaces are touching each other, so there will be frictional force. And now let's suppose at this point, see, this is rotating like this. So at this point, velocity will be in this direction, right? Like this, tangential. So for the first drum, it would be like this at the point of contact. And for the second drum, it would be again like this. That is but 2 omega r because the radius is 2. I'm talking about linear velocities, right? So let's suppose there is an observer sitting right here, observing these two drums. For him, the velocity at point of contact of this small drum will be relative velocity of these two, because when we know when two objects are moving in the same direction, relative velocity is given by the difference of velocities. So for him, its velocity would be 2 omega r minus omega r, that gives us omega r, but in this direction. Okay, so at this point, for this drum, velocity will be like this, that is omega r, and we know frictional forces always oppose the motion of the body. So if this is the velocity, this would be the direction of frictional force. But for the first drum, for the second drum, velocity would be like this and frictional force would be in this direction. So let's again draw these spheres and try to understand what is happening. Okay, so we have this drum and we have this bigger drum, and for this the force is in this direction, F, and for this the force is in this direction, F. Frictional forces, right? So now we can see these forces are opposite, but their magnitude will be equal because of Newton's third law. Every action has its equal and opposite reaction. Magnitude equal, but directions opposite. So that gives the answer to our first question. Second question is identify forces and torque external to the system just after contact. So we have to identify forces and external torque to the system just after contact. Let's consider in this diagram only. So this is separated by a distance of r and this is 2r. See what is happening. We know these drums are rotating, right? So for rotation we need torque. There should be some external force that is providing torque, and that force would be exactly opposite in direction to this force. If that's so, the direction of the force would be in this direction. Let's say F dash, and for this drum it would be in this direction, and it would be F double dash. Let's say F double dash. Okay. Now see, don't you think these forces are forming couple opposite forces, and they are at a distance of like perpendicular distance separated by perpendicular distance, so this would provide torque and they would rotate. But we also know that these drums are not translating. So for no translation, we need these external forces, that is F dash and F double dash, to be equal. Only when they are equal, these drums will rotate and they won't translate. So from this we conclude that F dash is equal to F double dash, right? Okay, now let's again draw these things, because now we need to find the torque. So torque, these are like this, right? This is R, this is 2R, and this is force F, or frictional force, and this is F again, and this is F dash, and this will also be F dash, because we proved that these two forces are equal. So now see, this distance between them, this F dash and F dash is 3R. Now this would produce couple equal magnitude and separated by a distance of 3R. See, now the distance is 3R, so we can write torque is equal to R perpendicular cross F. What is R perpendicular? 3R. And what is F? F dash. Okay, so this is our torque. Now, if we want to calculate the direction of torque, it would be in this, like say this is our F, extended F, and this is angle 90. And how do we calculate the direction? We cross them. R cross F. R cross F would be the direction in which our fingers curl, because it's given by the right hand rule. So if this is the direction, it would be in the anti-clockwise direction. So the direction of this torque is in anti-clockwise direction. Okay, that completes our second part. Third part is, what would be the ratio of final angular velocities when friction ceases? Okay, so let's say at that point when friction ceases, this starts rotating with an angular velocity omega 1, smaller drum, and the bigger one starts rotating with an angular velocity omega 2. So we say that friction has ceased. That means this can only happen when their velocities become equal. When their velocities become equal, there is no frictional force at the point of contact. So we conclude that omega 1r, that is the velocity of first drum, has to be equal to twice omega 2r. Only then friction would cease. From this we conclude that the ratio of omega 1 by omega 2 is equal to 2. So this is the ratio of angular velocities when friction ceases to exist. Thank you.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।